Yes, good morning. Today we are going to discuss the topic 6.1 verification of trigonometric identity. So before going to the identity, this is actually the whole topic is about the proof. The LHS is given a trigonometric functions, you have to find it the another identity, it is equal to the RHS. So before going to that one, so let us go with the simple basic definition of trigonometry. So if you have a triangle, so this is my theta, that right angle. What is this spot? This is my opposite, right? And this is the adjacent, and the slanting position we call it as hypothesis. So I can write it the basic definition of the trigonometry, that is sine. What is sine theta? What is sine theta? It is equal opposite over hype, opposite over hype, or otherwise in terms of the value I can write it this as y and this as x, and this is x and this is r. So I can write it like this. Now what about the cosine? Cosine theta, which is equal adjacent over hype, and tan theta, which is opposite over adjacent. So which in turn in terms of xy I can write it this one y over r, this is x over r, and this is y over x. So similarly I can find the next cosec. What is cosec theta? It is nothing but 1 over sine theta. 1 over sine theta. This is a flip. What is the flip of this? So this is r over y. And what about sec theta? The reciprocal of cosine. Cosine. So, and that cotan is the reciprocal of 1 over tan. And this is in terms of xy, I can write it this one, this is the flip of this. What is this? R over x, and here this is x over y. And one more thing I have to tell it here, this is tan theta is equal sine over cosine, and cotan is equal cosine over sine. So we are using this formula in the next upcoming problems. So whenever there is a cotan theta, we can write it the sine over cosine, and if it is tan theta is there, therefore I can write it as sine over cosine. This is already we know it. Okay. Now we are going to take the some identities, the very important identities. So first of all, here the very important sine theta or x, any variable. So sine square x plus cosine square x is equal 1. So this is a one identity. And here the next one we have sec square x minus tan square x is equal 1. So this is another identity. So this is a formula which is very useful in the proof of the identities. Now the next one here, it is cosec square x minus cotan square x is equal 1. So using this one I can, this is the main formula. So using this I can derive two formulas. How we will derive? So keeping sine square theta here, I will fix the cosine that side. What happened? You will get 1 minus cosine square. And similarly, I can prove the next one by fixing the cosine square x. You will get 1 minus sine square. So using one identity, I can prove, I can use two identities. By fixing sine, bring cosine that side, you will get 1 minus cosine square, and cosine square is equal 1 minus sine square. Similarly, we will do it the same story here. Suppose if I fix sec square here, so bring the tan here, it become 1 plus tan square, and tan x is equal sec square x minus 1. So this is the basic rules. So using one identity, I can prove the two. So similarly, here also we will use the same thing. Here sec square x is equal 1 plus cotan square x here, and then cotan square x is equal cosec square x minus 1. So these are the formulas. Now we are going to see the first problem. Verify. In the question it is given, verify the identity. Verify the identity. So what is the question it is given? The number 1, I take the first one, sine theta into cotan x into sec x is equal 1. I have to prove this is equal to 1. So how will you prove this one? Whenever you will find it this one, take the bigger term, bigger expansion. So this is my LHS, left hand side, and this is right hand side, RHS. So I will take LHS and proving RHS. The solution is take LHS. What is LHS given? Sine x into cotan x into sec x. So first convert all the term in terms of sine and cosine. What is this actually? Here you have this. I can write it cotan as what and sec as what. So I can write this one is same sin x, and what about the tan x? Cotan x, it is cosine over sine. And what about this one? I can write it, this is equal 1 over cosine x. What other term get cancelled? So here sine with the sine cancel, here cosine with the cosine cancel. The answer is equal, 1. So I prove this identity. This is equal RHS. Hence proof. Hence proved. So this is the one technique. You can go through all the concept, all the function, trigonometric function, convert in terms of sine and cosine. You will get easily the proof. And similarly the second one, I take the second one, verify the identity. It is given 1 minus 2 sine square x is equal here 2 cosine square x minus 1. So what happened here? This is equal, I will take RHS or LHS, no problem. Either you can take the RHS or LHS. So this is my LHS and this is RHS. So you have to take one side and prove the other side simultaneously at the end. So I will take the RHS. What is the RHS here? So 2 cosine square x minus 1. So here I have to reduce in terms of sign. So how will you find this one? Since we know it, what is cosine square x? Just now we have solved in the above. We have taken sine square x is equal what? Cosine square is equal 1 minus sine square. The same thing I will apply here. So what is this? This is equal 1 minus sine square x, and the remaining minus 1 is same, minus 1. Now multiply. What is the multiplication? So here you have 2 minus 2 sine square x minus 1, which in turn implies, so added the number with the number. What is the number with the number? Here 2 minus 1, you will get 1 minus 2 sine square x. So this is the proof. This is what you will get it in the LHS. This is the LHS. Hence proof. Hence it is proof. Hence it is proved. Hence it is proved. Now we will go to the next problem. What is the next one we have? Third one. Cosec square t minus cosine square t. Here cosec square t is equal 1. Now how will you do this one? So whenever you will find it this one, just take the common factor. What is the common factor here? Here also you have cosec square t, and here also cosec square t. So the t is a variable. It may be a x, theta, or t, whatever be the value, right? So I will take cosec square t outside, common factor. Now what are the remaining? Here you have, if you take outside, remaining is 1. 1 minus, we have taken this one outside, therefore the remaining is cosine. So we have taken here what? The LHS, the left hand side. Now what is this one actually? Cosec t, and since this value is equal sine square t, right? This is a very important thing. So it is 1 minus cosine square is sine square t, and this can be written as, how will you write this? This is equal 1 over sine square t. Here you have sine square t. Now what is cancel? Here you have cancel sine square t, sine square t. So the remaining is equal 1. So this is your right hand side. Hence proof. This is proof. Hence proved. So using the same technique, whenever you will have a common factor, just take the common factor outside. After that it become, the trigonometric function become very simple after you have to use the simple basic formulas. Now 4, last question here. Here you have to prove sine alpha over 1 plus cosine alpha is equal, here 1 minus cosine alpha over sine alpha. So here I have to take it this one LHS and proving the RHS. So I will take LHS. Here you have sine theta over 1 plus cosine theta. Whenever you will have here, you cannot simplify, you cannot take common factor, anything. Whenever you will find it this type, so just multiply with the conjugate of the denominator. What is the conjugate here? 1 plus is there, therefore I have to multiply 1 minus cosine alpha over 1 minus cosine alpha. If it is plus mawjood, therefore you have to write it minus. If it is minus is there, you have to multiply with the 1 plus. Just multiply the conjugate of the term, the denominator alone. So what is this one? After multiplying, what will get? Here you have sine theta as such 1 minus cosine alpha over what is this? This is actually, this is a plus b, a minus b. So I can write it this one, a square minus b square, and this is equal sine theta and 1 minus cosine theta over, and what is this one? 1 minus sine cosine square theta. 1 minus cosine square is sine square, right? So this is equal sine square alpha. Now what is the cancel? Here 1 time sine cancel, the power get cancelled. So the remaining is your answer. What is the remaining? So here you have 1 minus cosine alpha over sine alpha. So this is my right hand side. So hence it is proof. Now the same question, if it is asking like this, if the same question, it can be represented in this format. Show that this is the same fourth question, only the RHS will be changed. It is 1 plus cosine alpha is equal, here it is cosec alpha minus cotan alpha. See the difference between the last problem and this problem. Here you have what? This is your right hand side. Here this is your right hand side. Everything is same thing. At the last, just you have to, only one step is extra. So let us solve. So what you have to do? Just multiply, take the LHS and multiply with the RHS. So I can take here LHS. What is your LHS? Sine alpha over 1 plus cosine alpha. So I have to multiply with the conjugate. The conjugate is 1 minus cosine alpha over 1 minus cosine alpha, which in turn implies here sine alpha 1 minus cosine alpha over, it is a plus b, a minus b. I can write it as a square minus b square, which is equal sine alpha 1 minus cosine alpha. This is over, and this is what we have taken. 1 minus cosine square is the sine square, right? So I can write it here sine square. So what are the term get cancelled? Sine and 1 time get cancelled. The remaining you will have 1 minus cosine alpha over sine alpha. So we have stopped up to this in the last one, since the right hand side is given in this one. But here you have the different format. So I have to separate the numerator. So I can separate 1 over sine, and then I can separate cosine alpha over sine alpha. So what is the remaining you will have? Here you will find this is equal 1 over sine alpha minus cosine alpha over sine alpha. So this is equal cosec alpha minus this is cotan alpha. This is what it is given as a RHS. Hence it is proof. Hence it is proof. So this is all the types of problem we have covered here. In the first problem, just you have to take it the long expression and make it all the trigonometric functions as a sine and cosine. You will get the proof. In the second one, take one side and replace, you have cosine square 1 minus sine square, you will get the RHS and LHS. And here you have to take the common factor. Here in the last one, you have to multiply the conjugate. If the conjugate, the right hand side, it is given like this, stop here. If it is given like this, you have to separate like this. So with this we finish. Thank you.